In this video, we shall be looking at how to find derivative of a function using first principle approach. To do this, we have to apply this formula. F of x prime is equal to the limit as h approaches 0, f of x plus h minus f of x divided by h. The f of x prime is the first derivative itself. Assuming we're given that f of x is equal to x, then we can say that f of x plus h is same thing as x plus h, which is anywhere you see x, replace it with x plus h. So substituting this in this formula, we have that the first derivative, which is f of x prime, is equal to the limit as h approaches 0. Now f of x plus h is x plus h, which is x plus h minus f of x is x divided by h. This is equal to the limit as h approaches 0. X can cancel x, then I'm left with h divided by h. This is equal to the limit as h approaches 0. H divided by h will give me 1. And since there's no other h here, then our final answer will be equal to 1. Similarly, if f of x is equal to square root of x, and we are asked to find the first derivative, which is, let's find f of x prime. We all know that f of x prime is same thing as the limit as h approaches 0, f of x plus h minus f of x divided by h. Our f of x plus h is same thing as x square root of x plus h. So substituting f of x and f of x plus h in this formula, we have that f prime is equal to the limit as h approaches 0, x plus h, the square root of x plus h minus the square root of x divided by h. To solve this further, we have to multiply both sides, that's both the numerator and denominator, with the conjugate of this expression, and this is the limit h approaches 0, square root of x plus h minus square root of x divided by h multiplied by square root of x plus h plus x divided by the square root of x plus h plus square root of x. This is equal to the limit as h approaches 0, square root of x plus h multiplied by square root of x plus h will give me x plus h minus square root of x multiplied by square root of x will give me x divided by h into x plus h plus root x. This is equal to the limit as h approaches 0. Here x can cancel x, and we are left with h, which is h divided by h into square root of x plus h plus square root of x. Same way, h can cancel h, and we are left with the limit as h approaches 0, 1 divided by square root of x plus h plus square root of x. At this point, we have to apply our limit, which is 1 divided by square root of x plus h plus 0 plus square root of x. What this limit as h approaches 0, wherever you see h, you substitute with 0. Then this is equal to 1 divided by square root of x plus square root of x. And this is equal to 1 divided by 2 root x, because root x, square root of x plus square root of x will give me 2 square root of x, and this is our final answer. Assuming we are given that f of x is equal to 3x plus 2, then we are asked to find the first derivative of f of x. Then we already know that our formula is, which is f prime x is equal to the limit as h approaches 0, f of x plus h minus f of x divided by h. And from this, our f of x plus h is equal to 3 into x plus h plus 2, and this is equal to 3x plus 3h plus 2. Substituting f of x plus h and f of x in this formula, we have that f prime of x is equal to the limit as h approaches 0, 3x plus 3h plus 2 minus 3x plus 2 divided by h. This is equal to the limit as h approaches 0, 3x plus 3h plus 2 minus 3x minus 2 divided by h. Then 3x and 3x can cancel themselves, and 2 and minus 2 will go as well. So we are left with the limit as h approaches 0, 3h divided by h. And this is equal to the limit as h approaches 0. H can cancel h, and we're left with 3, and this will be equal to 3. If we are given f of x to be x squared, and we are asked to find the first derivative of this, remember our formula is equal to the limit as h approaches 0, f of x plus h minus f of x divided by h. Then our f of x plus h will be equal to x plus h squared, and this is something else, x plus h, x plus h. This is equal to x multiplied by x will give me x squared. X multiplied by h is xh. H multiplied by this is same thing as xh. And h multiplied by h is plus h squared. This is same thing as x squared plus xh plus xh will give me 2xh plus h squared. So this is our f of x. Substituting this is our f of x plus h. Substituting f of x plus h and f of x in this formula, we have that f prime of x is equal to the limit as h approaches 0, x squared plus 2xh plus h squared minus x squared divided by h. X squared and x squared can go. Then we are left with the limit as h approaches 0. This is 2xh plus h squared divided by h. We can decide to factor out h from this, and this will give me limit as h approaches 0. This is h into 2xh divided by h will give me 2x plus h squared divided by h will give me h. H. Then h can cancel h. I'm left with the limit as h approaches 0, 2x plus h. So applying our limit, we have that 2x plus 0 and 2x plus 0 is something as 2x. This is our final answer. Thank you for watching our video. Please don't forget to subscribe to this YouTube channel. If you have any question, feel free to email us at scienceelearningacademy@gmail.com. scienceelearningacademy@gmail.com. Thank you.